Hey, what's up? Welcome to Hooson. In this video, you will be learning how to make a simple yet fun endless runner where I will guide you through the entire game creation process. If you're just a beginner and you want to make your first game using Unity game engine, this is the tutorial for you. You will learn how to make a simple player controller, spawning obstacles, how to display score, looping background, and lastly, we will bring the game to another level by adding music and particle effect. After we have finished developing the game, you will learn how to publish your game on itch.io, and you can ask your family and friends to try it out. Impress them and get feedback so that you can improve as a game developer. I encourage you guys to finish the entire game creation process and don't give up halfway through. I promise you by the end of this tutorial, you will have a huge confidence boost as a game developer. Alright, let's begin. Firstly, we will need to create a new game project. Make sure you select the 2D template as we are making a 2D game and enter your project name. I'm going to call my project Stay Safe, as the theme of my 2D endless runner will be about avoiding the coronavirus. If you can't think of a name for your game yet, you can just name it 2D endless runner for now. Alright, let's create our game project. Once it finishes loading, it's time to configure our game project. Click on the File tab at the top of Unity and then Build Settings. In the Build Settings window, we want to change the platform to WebGL because we will be publishing the game on itch.io and we want our players to be able to play on the web browser. So let's select WebGL and click on Switch Platform. Once it finishes loading, close the Build Settings window and in your game panel, change the game resolution to be 16:9. You will see your game now in landscape mode. Next, we want to create a few folders in our game project so as to keep things organized. We want to create a script folder, a sprite folder, and a prefab folder. Next up, I'm going to import my game assets that I drew using Photoshop into my sprite folder. I will leave a link in the description below for you to download it. But I would highly recommend you guys to create your own game assets. I have a tutorial on 2D character creation and animation which you can check it out. For my game assets, the player character is riding on a strange-like looking plane, the obstacles will be the coronavirus, and the background will be a very simple background. Alright, it's time to do our player controller. Let's drag the player character into the game, and I want to rename it to Player Sprite. Let's create an empty game object called Player. Reset its transform component, and I want to make the player game object to be the parent of the player sprite. So simply drag the player sprite into the player game object. The player game object will act as a root for our character. Any components such as scripts or rigid body 2D will be added to it. Click on the player game object. Let's resize it as it's too big right now, and we want to add a rigid body 2D component. Adding a rigid body 2D puts this game object under the control of the physics engine. This way, we will be able to control our character from scripts. Freeze the Z rotation so that our character doesn't spin, and change the gravity scale to 0. The reason why we need to change the gravity scale to 0 is because we want the player to stay in the air. Now let's create a new C# script in our script folder and we will name it Player. Alright, let's open up the player script. Firstly, we will create a public float variable called player speed. This variable will dictate how fast our player will be moving. Now let's create a private rigid body 2D variable called RB. We need this variable because we will be using very simple physics to move our player. Lastly, we will create a private vector 2 called player direction. This variable will be used to process our player's input. In the start function, we want to fetch the rigid body 2D from our player game object. Next, we want to create a fixed update function below our update function. The difference between update and fixed update is that the update function is called once per frame. So almost anything that needs to be adjusted regularly happens here. Example like timers and detection of inputs are usually done in the update function. On the other hand, fixed update is used for being in step with the physics engine. So anything that needs to be applied to the rigid body should happen in fixed update. In the update function, let's create a float called direction y and it will be equals to input.getAxisRaw vertical. We will be using the direction y variable to detect which key the user is pressing. So if the user is pressing on the up arrow key, the direction Y variable will be equals to 1. And if the user is pressing on the down arrow key, the direction Y variable will be equals to -1. So now, player direction will be equals to new vector 2, and we will give a value of 0 for the x coordinate as we won't be moving our player on the x-axis. We will put the direction Y variable for the Y coordinate, and we will add dot normalized at the end to ensure our player's movement being consistent. Like I said earlier, we are doing all this in the update function because detection of inputs are usually done in the update function. Now in the fixed update function, rb.velocity equals to new vector 2, we will give a value of 0 for the x coordinate, and for the y coordinate, player direction.y times player speed. Like what I said earlier, anything that needs to be applied to the rigid body should happen in fixed update. Save the script and let's head back to Unity. Attach the player script to the player game object and let's give our player speed a value. Alright, let's give it a try. Perfect, we have completed our player controller. Now it's time to do our camera movement. We want the camera to be continuously moving forward. After that, we will attach the player game object to be a child of the camera so that it will look like the player is moving forward. But in reality, the player is just standing still and the only object moving is the camera. So let's create a new C# script called camera movement and let's open it up. Go ahead and delete the start function as we won't be using it, and we want to create a public float called camera speed. This variable will dictate how fast our camera will be moving. In the update function, we want to continuously change the x position of the camera. So transform.position plus equals to new vector 3 for the x coordinate, camera speed times time.delta time. And for the y and z coordinate, we will just give it a value of 0 as we don't want to change any of this position. Save the script and let's head back to Unity. Create a new game object and we will name it Game Manager. Reset its transform component and attach the camera movement script to it. Now we want to make the main camera and player game object to be children of the Game Manager. So let's select them and drag it into the Game Manager object. Let's give our camera speed a value and give it a try. Alright, you can see the player game object is constantly moving forward. Perfect, we have completed our camera movement. Now it's time to add our looping background into the game. Create a new quad and we will name this background. Reset its transform component and we can remove the mesh collider as we won't be using it. Select the background sprite, change the red mode to repeat, and click on apply to save the changes. Next, select the background game object and we want to drag our background sprite into it. In the shader option, we want to set it to unlit/texture. Let's scale up our background so that it covers the entire screen. Now we want our background to be a child of the Game Manager, so simply drag it into the Game Manager object. Alright, let's create a new C# script called looping background. Let's open it up. Create a public float called background speed. This variable will dictate how fast our background will be moving, and a public renderer called background renderer. Go ahead and delete the start function as we won't be using it, and in the update function, background renderer.material.main_texture_offset plus equals to new vector 2, background speed times time.delta time for the x coordinate, and a value of 0 for the y coordinate. Save the script and head back to Unity. Attach the looping background script to the background game object. I will give a value of 1 for the background speed and assign the mesh renderer to the background renderer variable. Let's try it out. Perfect, we have created our looping background. Now it's time to spawn our obstacles. Select your obstacle in your game project and drag it into the game. I'm going to rename it to Obstacle Sprite. And similar to what I've done for the player, we need to create a new game object called Obstacle. Reset its transform component and make the obstacle sprite the child of the obstacle game object. I'm going to resize it as it's too big right now, and then we want to make our obstacle into a prefab. So simply select the obstacle game object and drag it into our game project. So what is a prefab? Prefabs are a special type of component that allows fully configured game objects to be saved in the project for reuse. So if you select the obstacle prefab that you have created, you can see that it saves all the changes we have made to the object. And if I were to drag it back into the game, you can see that it is still the same and I do not have to reconfigure it all over again. Alright, let's delete the obstacles in our game for now. Create a new C# script called spawn obstacles and let's open it up. Firstly, create a public game object called obstacle. This variable will contain the obstacle that we want to spawn. Next, create 4 public float variables called maximum x, minimum x, maximum y, and minimum y. We need these 4 variables because we want our obstacles to spawn within the maximum and minimum range for each axis. Create another public float variable called time between spawn. This will dictate how much time is taken till the next obstacle appear. And lastly, a private float called spawn time. We can delete the start function as we won't be using it, and below the update function, let's create a new function called spawn. In the spawn function, create a float called randomX and it will be equals to random.range, and for the range, it will be between minimum x and maximum x. The reason why we are doing this is because we do not want our obstacles to always spawn on the same position. Let's do the same for the y-axis. Create a float called randomy and it will be equals to random.range, and for the range, it will be between minimum y and maximum y. Now we want to instantiate the obstacle. The position we want it to instantiate at will be transform.position plus new vector tree, random x for the x coordinate, random y for the y coordinate, and 0 for the z coordinate as we won't be using it. And lastly, the rotation will be transform.rotation. In the update function, we will first check if the time passed is greater than the spawn time. If it's greater, we will call the spawn function and then set spawn time to be equals to time.time plus time between spawn. Save the script and head back to Unity. Let's create a new game object called spawnPoint. We set its transform component and let's attach the spawn obstacle script to the spawnPoint game object. Drag your obstacle prefab and add it into the obstacle variable. For the minimum x and maximum x value, it's entirely up to you how far apart you want your obstacles to be. For me, I will just give a value of 3.5 for the maximum x and a value of 3 for the minimum x. For the maximum y and minimum y value, drag your obstacle prefab into the game again, move it all the way up and see what the highest y value is. Make sure the obstacle isn't getting cut off by the camera. Alright, my highest y value will be 4. And let's move all the way down to see what the lowest y value is. My lowest y value is around -4. Now your values don't have to be the same as mine if you are using your own obstacle asset, because the size of your obstacles might be different from mine. But if you're using my game asset, you can just follow my values. We can delete the obstacle prefab, and lastly, I will give the time between spawn a value of 0.6. The values of these variables are entirely up to you to decide. You can try many different values until you get the one you feel is best for your game. Next up, we will drag the spawn point out of the camera. Reason being, we do not want to spawn the obstacle right in front of our player. We want it somewhere out of the player's sight. Now we want our obstacle to move along with the camera. So select the spawn point game object and make it a child of the game manager object. Lastly, let's move our player character back a little. Alright, let's try it out. Perfect, we have managed to spawn our obstacles. Right now, we need to create some box colliders to prevent our player from moving out of the screen. Now let's create a new game object called borders and reset its transform component. Create another game object and let's name this top border. Reset its transform component as well, and we want to make this the child of the borders game object. With the top border object selected, let's add a box collider to the component. Resize it and make sure it covers the entire screen. Now let's move it up so that it's right above the screen. Now we need one at the bottom of the screen as well, so duplicate the top border game object and rename it to bottom border, and we will place it at the bottom of the screen. Now our player game object needs a box collider as well, So select the player and then add a box collider 2D component. Click on the edit collider icon and let's resize it so that it fits the entire player character. Lastly, we need to move our borders game object to be the child of the game manager object. This is so that it will move along with the camera. Let's give it a try. Nice, now the player won't move out of the screen anymore. Now we need to destroy the obstacles that are already out of the screen. So let's duplicate the bottom border and rename it to side border. Change the Y position to 0 so that it's back at the center and give the Z rotation a value of 90 so that our side border is vertical. Let's place it somewhere behind. Make sure it's not too near to the screen. Now we need to create a new tag for our borders. Select the borders game object and in the inspector tab, you can see a tag section right above the transform component. Click on it and you will be able to see a list of options. All the way at the bottom, click on Add Tag. Under the tag section, click on the plus icon, name our new tag Border and click Save. Select the borders game object again and we want to change its tag to border. Do the same for the top, bottom and side border. Alright, next up, let's click on our obstacle prefab and on the inspector tab, click on the open prefab button. Now we need to add a box collider for our obstacle as well. For me, my obstacle is in the shape of a circle, so I will use the circle collider 2D instead. If your obstacle is more of a rectangle shape, you should be using the box collider 2D. Let's click on the edit collider icon and change the size of our collider. Make sure it covers the entire obstacle. And lastly, check the is trigger option. Once you're done, create a new C# script and let's name it obstacle. Let's open up the obstacle script. Go ahead and delete the update function as we won't be using it, and we want to create a new private function called onTriggerEnter2D. So if the collision.tag is equals to border, we want to destroy this obstacle game object, which means whenever the obstacle touches an object with the border tag, it will get destroyed. Save the script and head back to Unity. Select the obstacle prefab and add the obstacle script to it. Lastly, we need to add a rigid body 2D component for our obstacle object as well. Increase the Z rotation and change the gravity scale to 0. The reason why we are doing this is because we need the rigid body component in order to receive trigger events in the obstacle script. Alright, now it's time to give it a try. Perfect. You can see that the obstacle gets destroyed whenever it touches the side border. Now we need to show the game over panel whenever the player touches the obstacle. So let's create a new panel and rename it to game over panel. Let's change it to a darker color. Select the canvas game object and we want to change the UI scale mode to scale with screen size. Reason being, we want our UI to scale with the size of the screen. So the X value will be 1600 and the Y value will be 900. Create a new image under the Game Over panel object and let's name it to Wooden Panel. Drag the Wooden Panel sprite into the source image and let's scale it up. Now let's create a new text under the Game Over panel as well. And we will name it Game Over Text. Change the text to Game Over. Change the alignment to center. Resize the text. Increase the font size. Let's change it to a darker color. And we will just place it at the top. Now we need a restart button to restart the game. So create a new button under the Game Over panel as well, and we will name it Restart Button. I'm going to drag my own mouse button sprite into the source image. Resize the button, change the text to restart, change it to a darker color, and increase the font size. Select the Game Over panel and let's disable it by simply unchecking the box right below the inspector window. Alright, let's open up our obstacle script again. Create a private game object called player. And in the start function, we want to set the player variable to be equals to GameObject.findGameObject with tag player. In the onTriggerEnter2D function, we will need to check if the player touches the obstacle. So else if collision.tag equals to player, we will destroy the player.gameObject. Save the script and head back to Unity. Create another C# script called Game Over and let's open it up. Create a public game object called GameOverPanel. This variable will be for us to assign the GameOverPanel. We can delete the start function as we won't be using it, and in the update function, if GameObject.findGameObject with tag player equals to null, we will set the GameOverPanel to be active. Now let's create a public restart function below the update function. So this function will be called when user clicks on the restart button. At the top, we want to add the Unity Engine.scene management namespace. Head back to the restart function, and we want to reload the scene when user clicks on the restart button. Save the script and head back to Unity. Attach the GameOver script to the Game Manager object and assign the GameOverPanel to it. Select the restart button, and we want to call the restart function when users click on the button. Lastly, select the player game object and change the tag to player. Alright, let's try it out. Perfect, we have completed our game over function, and the restart button is working as well. Now it's time to add a score for our endless runner. There are many different ways whereby you can count scores, but for this endless runner, the score will be based on how long the player can survive in the game. So the score will keep adding up every second. Create a new text under canvas and let's name it score text. Change the text to 0, change the alignment to the center, resize the text, increase the font size, let's change it to a darker color, and we will place it at the top. Now let's create a new C# script called Score Manager, and let's open it up. At the top, we want to add the Unity Engine.UI namespace. Now let's create a public text variable called score text. This variable will be for us to display the player's score. Create a private float called score. This variable will be for us to store the player's score. We can delete the start function as we won't be using it, and in the update function, we need to first check if the player is still alive, because we do not want to continue adding score once the player is dead. So if GameObject.findGameObject with tag player is not equals to null, we will add a value of 1 to the score variable every second. And we want to set the score text to be equals to integer score as we do not want the decimal place, and convert it to a string. Save the script and head back to Unity. Attach the Score Manager script to the score text game object and assign the score text to it. Alright, let's try it out. Perfect, we have created a score system for our game. Now let's add our background music into the game. I will leave a link in the description below for the music I'm using. Create a new C# script called background music, and let's open it up. We can delete the start and update function as we won't be using it, and we want to add the awake function instead. Firstly, we will create a private static variable of type background music and call it background music. In the awake function, we will check if background music equals to null. If it is, this will be the background music, and we do not want to destroy it. Else, we will destroy this game object. Save the script and head back to Unity. Create an empty game object and rename it to background music. Reset its transform component. Let's add an audio source component and add our background music script to it. Next, we will attach the music onto the audio clip. And lastly, check the loop option so that our music keeps repeating. Alright, let's give it a try. Perfect, we have added our background music. Now let's add some particle effect to make the game even better. Create a new particle system and reset its transform component. We have our own particle sprite which we want to use, so expand the renderer section. Let's change the material to sprite default. Check the texture sheet animation and expand it. We want to change the mode from grid to sprites. Now let's assign our particle sprite to it. Now you should see your own particle sprite appearing. Expand on the shape section, and I want to change the shape to cone. Now it's totally up to you on how you want your particle effects to be. Play around with the different options that are available. You can even change the rotation to make it appear differently. Now I want my particle to be coming from the right, so I will change the Y rotation to -90. Now the particle is coming from my right. I'm going to increase the radius to cover the entire screen and then shift my particle system to the right as I do not want it to appear in my player's side. In the particle system section, I'm going to scale down my particle as it's too big right now, so we can change it by reducing the value of the start size. Now head over to the start color, and I want to change the option to random between two colors. This allows us to choose between two colors for our particles. It's entirely up to you for the colors of your particles. I'm going to just choose two random colors. Now let's move over to the start speed, and this value will determine how fast your particle will be moving. So we could change the option to random between two constant, and this will allow our particles to have different speed. You can see that some are moving slower and some faster. You can play around with the other options like start lifetime, which determines the lifetime of the particles, and also the start rotation, which changes the particle's rotation. One tip in making great particle effect is to add randomness to your particles. That is why I always like to use the random between two constant option. So I'm going to add randomness to my particles on the start lifetime, start speed, and start color. Lastly, I'm going to check the pre-warm option so that my particles will be on my screen when I start the game. Now if you want to produce more particles, head over to the emission section and you can change the rate over time value. So a higher value will produce more particles. I highly recommend you guys to play around with the different settings you have for the particle system. You don't have to follow exactly like mine. Once you are done, make the particle system a child of the game manager object so that it moves along with the camera. Alright, let's give it a try. Perfect, we have completed our particle effect. Congratulations on completing this Endless Runner tutorial. Now it's time to publish your game on itch.io and you can show it to your family and friends. Head over to the File tab at the top of Unity and open Build Settings. Before we build our game, we need to make some minor changes to our player settings, so let's click on the Player Settings button. You can change the company name to your own name, or you can even put your company name if you have one. The product name will be the name of your game. Head over to the Resolution and Presentation section. Change the canvas width value to 1600, the canvas height value to 900, and we want to check the Run in Background option. Head over to the Publishing Settings section, and we want to change the compression format to disabled. Close the project settings window and it's time to build our project. Create a new folder and you can name the folder the name of your game, and we want to build our game into this folder. Once it finishes loading, we want to zip the folder and let's head over to itch.io. Log into your itch.io account and we want to click on the drop down box and select Upload New Project. Add a title and description for your game. For the classification, it will be Games. Kind of project will be HTML. For the pricing, it's entirely up to you if you want to make it free or paid. Now we want to upload the zip folder and we want to check this file will be played in the browser option. Change the width value to 1600 and height to 900. Check the full screen button and enable scroll bars option. Now you can slowly fill in the rest of the details, but one last important thing to take note, make sure you set the game to public in the visibility and access section so that others will be able to play your game. I want to congratulate you on completing this tutorial. I know it's not easy if this is your first time making a game, but I hope that you learned something from this tutorial. You can add more features to your 2D Endless Runner like making a main menu page or even adding an on-off sound button for your players. I would highly recommend you guys to add even more features so as to make your game even better. You can leave a link to your game on the comment section down below so that others can play your game as well. Don't forget to click on the like and subscribe button if you enjoyed this video, and I will catch you guys in the next one. Peace.